2.6, changing standard form into a normal number. What we need to do here is look at the index to determine if the number was divided or multiplied by a power of 10. So if it's been multiplied by a power of 10, it's going to have a positive power, like 10 to the power of 3, 10 to the power of 5. But if it's divided, it's going to be a negative power, like 10 to the power of minus 1, or 10 to the power of minus 6. And then we have to multiply it accordingly. So in part A, in example A, what we've got is 1.2 times 10 to the power of 3. Another way to think about that is that it's 1.2 times 10 cubed, which is 1,000. And 1.2 multiplied by 1,000 is 1,200. As a check, what we can do is we can see how many times the decimal point has been moved. So it was between the 1 and the 2, and then it's been moved 3 times. 1, 2, 3. So that looks good. Part B. It's 3.4 multiplied by 10 to the power of 1. Now 10 to the power of 1 is just 10. So 3.4 multiplied by 10 is 34. C. 9.2 times 10 to the power of 0. Now anything to the power of 0, remember, is 1. So it's just 9.2 multiplied by 1, which of course is 9.2. D. 7.234 multiplied by 10 to the 5. 10 to the 5 is 100,000 because it's a 1 with 5 zeros added on. So then 7 multiplied by 100,000 is going to be 700,000, but we've got the 234 as well, so it's 723,400. And we can check that by looking at how many times the decimal point is moved. It was between the 7 and the 2. It's been moved once, twice, 3, 4, 5 times, which matches the power. E. 2 times 10 to the power of 8. So 10 to the power of 8. This is 100 million. So 2 times 100 million is 200 million. And again, we can see that the decimal place has been moved from the 2. So there's 2 spaces to the first comma, another 3, and another 3. So that's a total of 8 times. Part F, we've got 5.6 times 10 to the minus 1. Now, whenever it's a minus 1, that's really meaning divided by 10 to the power of positive 1, so divided by 10. 5.6 divided by 10 is 0.56. And we can see that the decimal place has moved from between the 5 and the 6, 1 place to the left. G, 1.2 is a negative power, so it's going to be divided by, and 10 to the power of 2 is 100. So we're dividing by 100, which is 0.012. Again, as a check, we can see the decimal place has been moved twice from between the 1 and the 2. 1, 2, 2, between the 2 zeros there. H, 8.3. Again, it's a divided by because it's a negative power. 10 to the power of 5, which is 100,000. And what we're going to have there is that's going to equal 0.0000083. And we can see we want the decimal place to move 5 times, so it was in between the 8 and the 3, and it's been moved once, twice, 3, 4, 5 times. And then part I is 1.91356643, and it's multiplied by a negative power, so that's the same as divided by a million then. 10 to the power of 6 is a million. And we get 0.000000191356643. Let's count the number of times the decimal place is moved. It was between the 1 and the 9, and it's moved once, twice, 3 times, 4, 5, 6. And one of the things that we maybe have picked up by now is the link in negative powers. So if we look at example F, it had a power of -1, And in total in our answer we had 1 0. In G it was a -2, and in total we had 2 zeros. -5 in H, and we have a total of 1, 2, 3, 4, 5 zeros, including the one before the decimal point. And finally, part I, 10 to the -6, and we had 1, 2, 3, 4, 5, 6 zeros in total there.